Hello everyone. Today we will discuss the second application of operational amplifier, that is non-inverting amplifier. The circuit diagram of non-inverting amplifier is shown in this slide, in this circuit diagram, which consists of operational amplifier with two input terminal, positive and negative. The positive terminal of the op amp is called as non-inverting terminal. Negative terminal of op amp is called as inverting terminal. Since we are applying the input voltage Vi to the non-inverting terminal of the operational amplifier, it is called as non-inverting amplifier. And the inverting amplifier, to inverting amplifier we have connected resistance Ri, which is connected to the ground at point A. Then the voltage at point A Va is 0, and the output of the non-inverting amplifier Vout is again connected back to the inverting terminal at point B. So this is called as negative feedback. Since we are connecting the output voltage to the inverting terminal, that is negative terminal of the op amp, that's what we are calling this feedback as a negative feedback. So this negative feedback network is consist of the resistance Rf. Rf is feedback resistance, as we have discussed in the inverting amplifier also. Then if we apply the input voltage as a sine wave to the non-inverting terminal of op amp, then output of op amp will we will get it as a same output with same pace. There is no inversion between output and input. The same output we are going to get as a output as we have applied the input, but only thing is that there is a amplification. So there is the magnitude of output voltage is greater than the input voltage with same pace. So such configuration of operational amplifier, we are calling it as a non-inverting amplifier. In general, we can define the non-inverting amplifier with 2 points. The first one is the input voltage we are applying to the non-inverting, that is positive terminal of the op amp as shown in circuit diagram, and there is no phase shift between input and output. So that is nothing but there is 0-degree phase difference between input and output voltage as shown in the waveform. Let us study about the voltage gain of non-inverting amplifier. So we need to derive the expression for the voltage gain AV for the non-inverting amplifier also. Then the similar steps we are following as in case of the inverting amplifier. The first thing is that we need to calculate what is the current flowing through resistance Ri. So then how we are going to calculate the current flowing through resistance Ri? First we need to identify two end terminals of resistance Ri, that is point A and point B. The voltage difference between point A and point B will be the voltage drop across resistance Ri. Then according to Ohm's law, we can calculate the current flowing through resistance Ri, that is I equals to Va minus Vb divided by resistance Ri. So here Va minus Vb is a potential difference between point A and point B, which is also voltage drop across resistance Ri. Then this equation can be considered as equation number 1. Similarly, we need to calculate what is the current flowing through resistance Rf. Since the input impedance of operational amplifier is very much high, then all the current which is flowing through resistance Ri will be flowing through resistance Rf only. Then the current I through resistance RF can be calculated as phi B minus phi out divided by resistance RF. Here phi B is voltage at point B and phi out is the output voltage of the operational amplifier, and the point B and output terminal becomes the two end terminal of resistance RF. Then the potential difference between these 2 points is considered as the voltage drop across resistance RF. Then according to again Ohm's law, so we can calculate the current flowing through resistance RF as equation 2, that is I equals to phi B minus phi out divided by RF. Then from equation 1 and 2 in LHS we are having the same magnitude, that is I, that is current, and if we equate equation number 1 and 2, so we can have the equation as I equals to phi A minus phi B divided by Ri, that is equals to phi B minus phi out divided by resistance RF. Then again we need to apply the virtual ground concept here. So then according to virtual ground concept here, the non-inverting terminal is connected to the input voltage phi I, that is phi in. Then the voltage at point B is also equals to the input which is applied to the non-inverting terminal, that is phi in. So that we can write that according to virtual ground concept, we can write phi in is equals to phi B. Then if we substitute phi in equals to phi B in equation number 3, then equation 3 becomes I equals to minus phi B divided by Ri. Why? Because phi A is 0. The point A is connected to ground, that's what the phi A is 0. So the I equals to, it becomes I equals to minus phi B divided by Ri, that is equals to in place of phi B we substitute phi in, that is phi in minus phi out divided by RF. Then if we consider this equation as equation number 4, then if we simplify such that to define the voltage gain, that is the how to define the voltage gain of the circuit, that is the voltage gain is defined as the ratio of output voltage to the input voltage, or the output voltage divided by input voltage is defined as a voltage gain. Now the equation 4 can be simplified in terms of output voltage divided by input voltage, which is voltage gain AV. So then you are going to get the equation as AV equals to output voltage divided by input voltage equals to 1 plus RF divided by R1, where RF is the feedback resistance, R1 is R1, or you can call it as a Ri. Ri is the input resistance. So this is the voltage gain of non-inverting amplifier. AV equals to 1 plus RF divided by R1. This is all about non-inverting amplifier application. Thank you.